Hello everyone. Welcome back to CloudCraft podcast. My name is George and today we are talking one of the most critical yet often overlooked aspect of managing a cloud environment, visibility. If you have ever been in a situation where a service is failing or you suspect a security breach but you can't quite point to where the traffic is stopping. You know how frustrating the black box of cloud networking can feel. In a traditional data center, you might have had physical taps or span ports to see what was happening in the wire. In AWS, we don't have physical wires, but we do have something even more powerful: integrated logging. In this episode, we are going to deep into two of the most important logging tools in your AWS arsenal: VPC FlowLogs and Application Load Balancer ELB access logs. You might be thinking, don't they both just log traffic? Well, yes and no. They operate at different layers and provide very different insight. Think of VPC flow logs as your big picture tool. It's like having a security camera at every intersection in a city, showing you which cars, here we can say IP packets, are moving between subnet and on the other hand, LB access logs are like a detailed guest list and transcript at the front door of your specific building. They tell you exactly who requested what browser they used, and how long your application took to answer. Today, we will look at how they work, what they actually capture, and most importantly, how to use that data to solve real world problems. By the end of this session, you will know exactly which log to turn on when things go sideways, how to interpret those cryptic reject messages, and why you might be seeing gaps in your data if you aren't careful about what these logs don't capture. So let's start with the foundation of VPC networking, VPC flow log. If you want to understand what is happening inside your virtual private cloud, you start with VPC FlowLogs. The feature is your primary way to capture information about the IP traffic going to and from network interfaces, those ENIs in your VPC. The beauty of VPC FlowLogs lies in their architecture. One of the biggest concerns architects have when enabling logging is performance. Will this slow down my network? With VPC FlowLogs, the answer is resounding no. AWS collect this flow log data outside the path of your network traffic. This means that enabling or even deleting a flow log has zero impact on your network throughput or latency. You get total visibility without any performance tax. One of the first things you need to decide is the scope. You don't have to log everything if you don't want to. You can enable flow logs at the VPC level, the subnet level, or even drill down to a single elastic network interface. When you set this up, you create what AWS calls a subscription. This is essentially telling AWS where to send the data. You have three main options: AWS CloudWatch Logs, Amazon S3, or Amazon Data Firehose. If you want to set up real-time alarms like alert me if I see more than 100 rejects in a minute, CloudWatch is best bet. If you are looking at long-term archival or using big data tools like Athena or SQL-based analysis, S3 is the way to go. So look at the anatomy of a flow log record. What does a flow log actually look like? Each record is a summary of a flow observed over a specific capture window, which is typically about 10 minutes. The field's highly structured. You are going to see the source and destination IP address, the source and destination port, and the protocol number. But the most important field for most of us in the action, VPC flow log will tell you if the traffic was accepted or rejected. This is based entirely on your security groups and network ACLs. If you see a reject in your logs, you know immediately that your security rules are blocking that specific traffic. It is the ultimate smoking gun for connectivity troubleshooting. Now, I want to pause here for a second because there are some critical gotchas. Look on the details of what is not logged. You might enable FlowLogs and realize you can't find specific traffic you know is happening. That is because there are several types of traffic that VPC flow logs explicitly ignore. First, they don't log traffic to Amazon DNS service. So, if you are trying to troubleshoot a DNS resolution issue using flow logs, you won't see those queries to the VPC's internal DNS. Second, they don't capture Windows license activation traffic for license provided by Amazon. They also skip requests for instance metadata, that familiar IP address. And finally, DHCP requests and responses are left out. Knowing this exclusion is just as important as knowing what is there because it prevents you from hunting for ghost data that will never appear in the log. Before we move on to the load balances, let us talk about the patience factor. When you first enable a VPC flow log, don't expect to see data in 5 seconds. It takes about 15 minutes for the log group to be created and for those first records to become visible in the console. And of course, we have to talk about cost. While you are charged for the collection itself in terms of performance, you are charged for the storage and ingestion. Typically, you are looking at around a cent for injection into CloudWatch and a few cents per gig for monthly archiving. It's a small price for the security and troubleshooting phase of mind it provides, but it's something to watch if you have a very chatty network. Now that we have covered the big picture network view with VPC FlowLog, let's shift our focus higher up the stack to the application load balancer access logs. While flow logs give you the IP level visibility, AWS access logs provide the granular application specific details of every request hitting your load balance. Think of these as your friend or log. They capture detailed information including the time the request was received, client IP address, latencies, request path, and the exact server response. Just like FlowLogs, this feature is disabled by default. So you must explicitly enable it for each load balancer. Unlike FlowLogs, which can go to a few different places, ELB access logs are stored exclusively as compressed files in an Amazon S3 bucket that you specify. AWS publishes a log file for each load balancer node every 5 minutes, which is a tighter window than the roughly 10 minutes capture window we see with VPC flow log. It is important to remember that log delivery is eventually consistent. If your site has high traffic, the load balancer may deliver multiple logs for the same time period. While you do have to pay for the S3 storage cost, AWS does not charge you for the bandwidth used to send these log files from the load balancer to your bucket. Each log entry represents a single request or a connection in the case of WebSocket. One of the most powerful things about these logs is that they record everything, including requests that never actually reach your application target. For example, if a client sends a malformed request or if your AWS path blocks a request, it is still logged here so you can investigate why. Let's talk about some of the high value fields you will find in an entry. First, you have the type. This tells you the protocol used, whether it was standard HTTP or HTTPS or more modern protocols like H2 or gRPC. Next, we have the status code, and this is where many people get confused. You get two different status codes, the ELB status code and the target status code. The ELB status code is what the load balancer actually sends back to the user. The target status code is what your backend application, your EC2 instance or Lambda function, send to the load balancer. If you see a 502 BART gateway in the ELB status code, but a hyphen in the target status code, you know the load balancer couldn't even connect to your application to get a response. For the performance tuners out there, the latency fields are your best friend. There are three primary timers. The first one, request processing time. How long it took the load balancer to receive the request and send it to a target. The next one, target processing time. This is the big one. It is the time from when the load balancer sent the request to the target until the target started sending back response headers. This essentially measures how fast your application is processing the logic. And the last one, response processing time. How long the load balancer took to send that response back to the client. If your users are complaining about slowness, where the delay is happening. Let's look on advanced diagnostic. ELB access logs have also evolved to handle more complex security issues. They now include classification and classification reason fields. These are used for distinct mitigation, identifying requests don't comply with RFC 7230. If a request is flagged as savory or ambiguous because of things like bad content length headers or multiple transfer encoding headers, you will see a specific code like both tectile present or but header. You also get rich metadata like the user agent string, which can be up to 8 KB, identifying the client browser or device. For HTTPS listeners, you will see the specific SSL cipher and protocol use, which is invaluable for auditing security complaints and ensuring you aren't supporting outdated, vulnerable protocols. Before we move on, I have to mention a small but vital disclaimer in the documentation. Elastic load balancing logs request on a best effort basis. While they are incredibly reliable, AWS recommends using them to understand the nature of your request rather than as a 100% complete accounting of every single request for financial or legal auditing purpose. Let's look on how to analyze this data. Because these logs can reach gigabits in size for high traffic sites, you shouldn't try to read them manually. The pros use Athena, which allows you to run standard SQL queries directly against your log files sitting in S3. You can also pipe them into third-party tools like Splunk or Sumo Logic for real-time dashboards. Now look on a couple of examples. For VPC FlowLogs, a highly effective strategy is to create CloudWatch alarms that fire if specific types of traffic are or use metrics to identify border trends and patterns. This is particularly useful for diagnosing overlay restrictive. For instance, if you are seeing a high volume of reject actions for a specific port, do you have immediate proof that a security group or Network ACL is blocking traffic that should be allowed? Scenario 1. My app is slow. When a user complains about slowness, VPC FlowLogs won't help much because they only track packet counts and bytes. Instead, they need the access log. Here you can look at the target processing time to see exactly how many seconds it took for your backend target to respond. If the request processing time is high, the delay is happening between the client and the load balancer. But the target processing time is the culprit, the bottleneck is inside the application code. Scenario, I'm getting 502 but gateway errors. This is a classic load balancer issue. You will want to check the ELB status code versus the target status code in your ELB logs. If the target status code is a hyphen, it means the connection never even reached your target. Perhaps because of a 10-second TCP connection timeout, if the ELB status code shows a 403. You can check the action executed field to see if AWS WAF was the component that rejected the request. Look on one more scenario. If my network under attack, if you suspect a brute force attack or a port scan, VPC FlowLogs are your best friend. They allow you to monitor all traffic reaching your instance and determine direction of the traffic to and from your network interfaces. You can see if an unusual number of external IP addresses are trying to hit ports that you aren't even open, which is the big picture visibility you can get from application level logs alone. Let me conclude today's session. The most important takeaway today is that both VPC flow logs and ELB access logs are optional features that are disabled by default. Don't wait for an outage to happen before you turn them. Because VPC flow logs are collected outside the path of your network traffic, they carry no risk to network performance, making them a no-brainer for security and connectivity audits. For both types of logs, remember to be mindful of storage. While you can store log files in S3 for as long as you want, it is best practice to define Amazon S3 lifecycle rules to automatically archive or delete all logs to manage your cost. Whether you are hunting down a finite for gateway timeout in your ELB logs or auditing reject action in your VPC. These tools provide the transparency you need to run a secure, high-performing environment on AWS. Thanks for listening and happy logging.